The demands of the modern life sciences industry are putting demands on the QC analytical departments of companies that have previously not been seen. The function has typically been viewed as an add-on requirement at the end of manufacturing, necessary to test and release the results for the quality assurance group to release the product. Today, this function, whilst remaining part of the quality function, is nevertheless a significant part of the overall production process, and as such, needs to be integrated to generate the efficiencies and productivity gains associated with modern life sciences process manufacturing. The key then is the integration of the function with manufacturing and quality assurance functions, and the application of appropriate process excellence principles to generate peak performance and sustainable quality compliance. Key components of this operational excellence approach involve those that address the improvement of efficiency and a reduction in compliance problems. To address this, there is a need to analyze the organizational focus as it relates to improved business problems. This is effected through a combination use of KPIs, metrics, focused intensive skills-based learning, and a replacement of paper-based systems with electronic systems. This improvement in business processes is achieved through the implementation of a variety of tools and techniques, but key among them are 5S, VSM to identify waste, poke-yoke mistake proofing, process leveling, standardized work patterns, use of visual management dashboard, and a smart board's Kaizen continuous improvement events. Married with these techniques and tools is the need for electronic technology, since this provides the complete integrated approach for gathering, analyzing, and manipulating data sets. Important features here include the LIMS laboratory information, management system, data management system, and barcoding for identification. Here we see a stylized architecture for a modern laboratory approach, which highlights the various data inputs that may be received and how those can be efficiently managed to maintain quality compliance and productivity. Key among these is how key electronic systems can impact daily efficiency. SMART works closely with its clients and vendors that have these technologies to enable this type of approach to be implemented. An area that's problematic for laboratories is how to best structure its resources, and that includes both equipment and analysts. In most conventional laboratories, there's the characteristic and flow of samples en masse, followed by periods of zero flow. This unbalanced flow leads to an inefficient use of resources because the laboratory is either operating as a feast or famine mode. A better use of resources is achieved through a balanced flow using Hijunket devices, which enable the flow to be leveled. Through a regular arrival and processing of samples, more samples can be processed, cycle times can be reduced, and human errors may be eliminated. Organizational robustness is achieved through the implementation of a 5S approach. This involves sort, straighten, shine, standardize, sustain. First, the clutter and unused equipment is removed as part of sort. Then the actual equipment to be used in the new layout is planned and arranged. Next, the facility equipment is made to shine. This includes being clean. This includes operating as it was designed. Once the above three elements have been addressed, the goal is to fully standardize the operation, so each piece of equipment operates equivalently according to its specification and design features. Fundamental to transforming operations in the laboratory is to understand how everything operates, and particularly where the areas of waste and inefficiency, non-value added, are. This is best achieved through value stream mapping. Now that we have lots of data, the plan needs to set up a structure that focuses on continuous improvement. We achieve this through Kaizen events and sometimes Kaizen Blitz. Using a PDCA methodology is key in achieving this. Looking at our process and data sets, we may decide on an improvement. To do this, we plan the improvement. Next, we perform the change we specify. As a follow-up, we check whether the change has had the appropriate result. Finally, based upon the analysis, we make additional tweaks to improve our result. It's important to note that although this is usually not a one-time event, it can be in specific circumstances. More often, however, the process will be one of several rounds of the cycle to arrive at the result designed. Here we see the storyboard chart we can use to develop and record our ideas, as well as our outcomes and successes. Using a Hijunka tool like a rhythm wheel, we can space out various analyses and achieve a balanced flow modulation, which leads to greater productivity and fewer mistakes. Through the use of agreed-upon analysis times, customer delivery times, and a mechanism for deviation, balanced flow modulation can be a positive outcome, and this can have a profound impact when integrated with the manufacturing production group. This type of integrated teamwork approach, meshed with the modern electronic solutions, wins the day in generating a style of production that is unmatched in terms of output by conventional operating systems. Our Lean Lab transformational program sets out an achievable, test-tried system that will deliver improved productivity, sustainable compliance, and a working environment that will foster a more enjoyable employee experience. This results in a greater degree of working cooperation that will assure better delivery outcomes and healthy customer relationships.